Hey, algebra students. In this lesson, we are going to talk about multiplying and dividing rational expressions. And really, there's one key thing into this lesson, and it is figuring out how to factor terms and make things cancel. That's what we're going to spend a lot of time in this lesson doing. And that's why we're going to spend most of the time in this lesson actually working practice problems so I can show you how you can find factors and then make those factors cancel. Now, the first few problems are going to look like what we've done before when we need to find these products. So we're just going to cancel on the top and the bottom here, just like we've done. One of the differences is in this lesson, eventually we're going to be dividing fractions, which means we're going to have to use keep, flip, change to turn the fractions into a multiplication problem. But then things are going to be just like they are up here. And then finally, like I mentioned at the very beginning, one of the things we really got to get good at here by the end of this is finding these factors inside trinomials and other terms, and then canceling out like factors like x plus 3 as a factor. Okay, you'll see what I mean by that when we get to it. Let's just get started. Up at the top here, by the way, it mentions that when we multiply rational expressions, all we do is we multiply across the top of the fraction, multiply across the bottom of the fraction. What that means is that anything in either fraction could cancel anything in the bottom of either fraction. So anything in the top of the numerator of either fraction could cancel anything in the denominator of either fraction. Because when we multiply together, it's just going to collect all of these terms together in the numerator and then all the terms together in the denominator. When we divide, we need to actually do keep, flip, change and change it into a multiplication problem. And then what I just said applies. All right, so let's get started. Letter A. So for letter A, we have these terms, 4z to the fifth, q to the eighth. And what I'm going to do is I am just going to multiply these together right away. So 4z to the fifth, q to the eighth times 14 q z to the fourth. Okay, so hold on a second. This is going to be 4 times 14. I can combine those terms because it's just a constant. 4 times 14 is going to be, let's see, what is that? It's, 56. 4 times 10 is 40. 40. 4 times 4 is 16, 56. So that's going to change this. Instead of 4 times 14, I'm just going to write 56. I have z to the fifth. I'm going to multiply that by z to the fourth. That's going to change this from z to the fifth to z to the ninth. Because remember, this is z times z times z times z times z. And then I'm going to multiply it times z times z times z times z. That's a total of 9 z's. So that 9 counts up all the z's. And then q to the eighth times q, why, that's going to be q to the ninth. All right, I've taken care of the multiplication on the top of my fraction in the first step I've written out. Now I'm going to put a fraction bar in here, the cheesy way by just underlining things. And then on the bottom here, let's put our denominator. We're going to have 14 q z to the seventh, okay, times, and I'm just going to multiply across in the denominator. Well, 14 times 3 is 42. Q times q to the fourth, I'm multiplying a q to the fourth times its original q. That's going to be q to the fifth. And then z to the seventh times z is going to give me z to the eighth. All right, now I've got my numerator, I've got my denominator. The last step is to simplify what's on both the top and the bottom of the fraction. So I'm going to write out a brand new fraction over here. Now let me think about this. 56 and 42 are both divisible by 14. Hey, one thing I could have done to really simplify this for myself is in this original problem, because, like I said, anything on the top of the fraction on either side can cancel anything in the bottom. I could have right away just canceled out this 14 and this 14 because one of them's on the top in one fraction, one of them's on the bottom. That would have made it really obvious that this is going to be 4 over 3. But I know that if I divide 56 by 14, I'm going to end up with 4. So I'm going to put 4 on the top of this fraction. And then I'm going to have a 3 on the bottom of this fraction. It's going to end up being 4 thirds when I cancel 14 out of the 56 and the 42. Now, do any of my z's cancel? Well, all 8 z's are going to cancel on the bottom, and they're going to cancel out 8 of the z's on the top. So I'm left with 4 times 1z on top. 4 times z. And then let's see, all of these q's on the bottom are going to cancel out with q's on the top. 5 of these are going to cancel out 4 of my q to the ninth. So I'm left with q to the fourth on top. Okay? And this is going to be my final fraction, 4 times z times q over 3. Let's just make sure I did all of that right. 4 q to the fourth z over 3. They just put q, they put it in alphabetical order. Totally makes sense to do it that way. There we go. All right, let's see if we can do letter B. B is going to work out much the same. So in letter B, we have on top 5x squared times 4x squared. Well, that's really easy for me to just combine right away. When I multiply those, it's going to become 20x to the fourth. Okay, and then in the denominator, I have 7y to the fourth times 9. That's going to be 63y to the seventh, the denominator. Now, just as important as knowing what you can cancel is knowing what you can't cancel. I have no factors in common between 20, which breaks down to 2 times 2 times 5, and 63, which is going to break down to what, 3 times 3 times 7. There's no factors in common between those two, so I can't cancel out any common factors there. And x has a different base. X to the fourth has a different base than y to the seventh, so there's nothing I can cancel there. This is just going to become 20x to the fourth over 63y to the seventh. Sometimes Saxon is going to check to make sure you won't simplify things that you can't. Right, next, multiply and simplify our answer here. So what we're going to end up with is 6 times, let's see, and anytime we have a number that's not a fraction, we can envision that this is being divided by 1. Okay, so here's what we're going to do. We're going to do 6 times, and then x squared minus 6x minus 27. Well, wait a second, that's a trinomial. What you should do in this lesson is anytime you run into trinomial, you have to factor it. All right, so we're going to factor this trinomial, and we're going to ask ourselves, what are the factors of negative 27 that add up to negative 6? Well, 9 times 3 is negative 27. That's promising. So if I do plus 3 minus 9, that gives me negative 6. So this would be x plus 3, x minus 9. Okay? This expression up here is the same as what's over here. What's here? So 6 times this divided by, and let's see, in our denominator, we're going to have what? 2x minus 18. But 2x minus 18, I could factor a 2 out of there. That's 2x minus 9. Okay, now, do I have any factors in common in my numerator and my denominator? Well, I notice that this x minus 9 matches x minus 9 in the denominator. Those two are going to cancel. Additionally, this 2 in the denominator cancels with the 6 because 6 has 2 as a factor. And when I cancel this 2, the 6 on the top becomes a 3. So my answer for this one is very simply just going to be 3x plus 3. 3 times x plus 3. Those are the only factors that I have left. Let's just see if we did this one right. Boom, there's the answer. All right, let's move on to letter C. In letter C, we have, I'm sorry, letter D. We just did letter C. Okay, in letter D, we have 8m plus 6m squared n times 8m on top. What are we going to do with that? Well, might as well just write it out. It's going to become 8m times, in parentheses, 8m plus 6m squared n. Okay, so that's not very promising to work with, but we'll see what happens here as we go along. That's going to be divided by, and let's take a look at our factors in the denominator. 12. Okay, here, let me just make sure that looks right. So this will be 12 times 24m plus 8mn. Well, one thing I'm going to notice here is that I can factor an 8m out of the denominator here. So if I pull out an 8m from this, this becomes 3, and this becomes just n. So 8m times 3 plus n in the denominator times 12. But one of the things I notice is that I have an 8m as a factor in the denominator and an 8m as a factor in the numerator. Anytime I have the same factor in the numerator and denominator, I can cancel. Okay, I'm going to rewrite this and we're going to see if there's anything else we could do with it. I think there's going to be. So in the numerator, now this gives me 8m plus 6m squared n. Okay. Hey, is there anything I can factor out of there right away? Well, if I look at this, I notice I could pull a 2m out of both of these terms. 2m pulled out of 8m gives me 4. And 2m pulled out of 6m squared n gives me 3mn. Okay, so 4 minus 3mn on top, 4 plus 3mn. And then on the bottom of this, we have 12 times 3 plus n. Okay, now I'm just looking. There's nothing that I can simplify in here versus down here because these are different factors. 4 plus 3mn is different than 3 plus n. I can simplify and get rid of this 2 up top and change this 12 in the bottom to 6. All I did was I factored out a 2 from each of those numbers and canceled. And I think that's all I'm going to be able to do. Let's just check the answer and see if I got this one right. M times 4 plus 3mn over 6 times 3 plus n. That's all I can do. That's what my simplified form is going to be.